But good evening. Am I audible?
Yes, sir.
Okay. Only two person have joined. Maybe we can wait 5 more minutes or it will start. Huh? Okay, so maybe we can start. A few people have joined. So we'll be discussing uh, today, starting from MPH-007, classical electrodynamics. And it is assumed that all of you have gone through classical electrostatics. uh, So we'll be more concerned into the dynamics part now, or motion of charge, what happens while there is a motion of charge. So again, if you uh, go to e-GAN course of IGNO, then you will get all the study material, and I hope all of you have got the PDF copy of the study material for MPH-007. Have you? ସମସ୍ତେ study material ପାଇଛନ୍ତି ତ?
Yes, sir.
Okay, good. So then we'll be starting with the block 1, which is mainly dealing with Maxwell's equation for electromagnetic waves and dynamics of charged particle. Okay, so if we move over to uh, this part, it is quite nicely actually explained here over here. Um, so if you go to block 1, uh, so fundamentals concepts of electrodynamics such as Maxwell's equation, uh, electromagnetic uh, energy, momentum, electromagnetic waves, dynamics of charge particle in electric and magnetic field. All these things will be discussed in reference to Maxwell's equation. Okay. If you go to block number 2, so there it will be mostly propagation of electromagnetic waves. So block 1 will be developing electromagnetic. How exactly we're getting to know electromagnetic wave. And block 2 will be propagation of electromagnetic waves in different media. ବିଭିନ୍ନ ମିଡିୟମ ରେ ଇଲେକ୍ଟ୍ରୋମାଗ୍ନେଟିକ ୱେଭ୍ସ କୋଉ ଭଳିଆ ଯାଉଛି ତାର ଇକ୍ୱେସନ୍ସ ଗୁଡା ଡିସ୍କସ କରାଯିବ ବ୍ଲକ 2 ରେ ଫୋକସ ଅଫ that block is basically to discuss basic concepts required for rigorous theoretical analysis of optical phenomena such as reflection, refraction, dispersion. eh, Because light is electromagnetic wave. So once we understand, if we try to explain what is happening in optics mathematically, then or moving away from ray optics. So whatever you have studied in optics in BSc, mostly the mathematics is for ray optics. For wave optics, relating like reflection, refraction, and dispersion. So in that case, we have to treat light as an electromagnetic wave, and based on the mathematics of electromagnetic waves, we have to explain all the optical phenomena. And we can also do the theoretical predictions made with respect to this kind of reflection and refraction and dispersion. Block 3 is mostly concentrating on radiating systems and radiation from moving charges, because once charge starts moving, it will radiate energy. In the context of electromagnetism, a radiating system refers to systems that emit electromagnetic radiation, such as radio waves, microwaves, infrared radiation, visible light, ultraviolet, X-ray, gamma ray. Yeah. And block 4 basically discuss about electrodynamic topics like relativistic electrodynamics and investigate the nature of Maxwell's equation in inertial frames, and then when you move over to Lorentz, do the Lorentz transformation, what will happen to the so that is more like relativistic electrodynamics. So what happens when a charged particle start moving in the speed of light? So what exactly will happen? So then we have to take into account relativity and mix with our electrodynamics and see what exactly is happening. Okay, this is how this whole MPH-007 is spread. So we'll start with block 1. I guess once you understand block one or the basics of Maxwell's equation, then it will be much easier for you to understand other parts of this paper, because it's very much important that you understand Maxwell's equations and electromagnetic waves. Once you know electromagnetic waves, then you can develop the math, or you can understand the mathematics related to electromagnetic waves in other parts like radiation and relativistic treatment. Okay, so moving directly to Maxwell's equation. I guess Maxwell's equation all of you have studied in BSc. Have you? समझ में मैक्सवेल को इक्वेशन पढ़ते लो बीएससी में मैं पढ़ी ना
Yes, sir.
yeah so we'll be revisiting that Maxwell's equation and try to develop the concept of electromagnetic waves from Maxwell's equation. Okay, so basically Maxwell's equations are not like completely new. There were equations like Gauss law, Faraday's law, Ampere's law. Huh. But what happens? Maxwell's kind of very nicely interrelated them and said that these four equations will govern all the electromagnetic or other electromagnetic phenomena. I mean, you can explain all electromagnetic phenomena using this Maxwell's equations. Okay, so the expected outcome from this part is basically to understand or explain the concept of electromotive force, and then meaning of flux of a vector field through a surface, Faraday's law, and explain the minus sign in Faraday's law and appreciate the difference in the nature of electric field induced by a changing magnetic field and the electric field due to charges. Okay. Then let us look at Faraday's law. So what exactly Faraday's law said? Faraday's law टा कौन कार मने अछि Faraday's law?
When a coil moving around a magnet
Mhm.
and EMF is induced to at the two ends of the coil.
Right. But if we try to write it in or explain it in mathematical form, there is something called flux. Flux.
Of
Eh?
phi is equal
Yes.
E is equal to del phi by
E is equal to d phi by dt, but with a negative sign, right? So that part you are getting over here. E is equal to minus d phi m by dt. Let me see my pen. Is it working? Just one second.
sound.
All right. So this is basically the equation, right? That way. My screen is visible to everyone, right? Is my screen visible to everybody?
Clearly visible.
Okay, good. So then this E induced EMF is equal to minus d phi m by dt, right? And what is phi m? Phi m basically is the magnetic flux, magnetic flux linked to a particular circuit or particular current loop. Okay, ମାନେ ଯଦି ଗୋଟେ ତାରଟେ ନବା, because charge only will move, charge will not move in free space. For motion of charge, what you need? A conducting path, right? The conducting path means you need a wire. The simplest form is you need a wire so that charge can move in a wire, metal wire. But if we make it a closed loop and we try to move that loop, towards or away from a magnet, then what will happen? The flux associated with that loop will change. So if with respect to time this flux changes, then that will induce an EMF in the wire. So that is a voltage. And if that is kind of a closed circuit, then you can clearly see, current is flowing, giving rise to some, lighting of a lamp or something like that. That you have studied in schools also. So this is the mathematical form. We say the E is equal to minus d phi by dt. But why there is a minus sign? Why
The
there is a
direction of the
minus?
induced the opposite to the that produce it. Against that
Yes,
produce it.
yes. So basically, the idea is it will try to. So the induced EMF will be in such a direction that it will try to oppose this change in flux. So forcefully, if we try to change the flux, then the induced EMF will be in such a direction that it will try to oppose the change in flux. That is why we have a negative sign. Okay, so that's what it is telling you. Faraday's law, if you concentrate over here, says that Faraday's law states that EMF induced in any loop, coil, or circuit is proportional to the negative rate of change of magnetic flux phi m through it. E is the induced EMF in any loop, or phi m is the magnetic flux. We can rewrite Faraday's law in a 1.1 in the form that we omit any reference to the circuit. How? By writing. To do so, we may recall that by definition, induced EMF is equal to, this is important, the induced EMF is equal to work per unit charge done on a test charge that is moved around a circuit. So that means E dot dl closed circuit. So E dot dl over a closed circuit. Okay. E dot dl. So that can be what is the direction of dl? If dl is like dl is a small element of the wire.
Along the current.
And yes. So we can, so this equation we can try to write E dot t cap, where t cap denotes the unit vector. You can write n cap. Many times we actually write E dot n cap dr. Here it is written t cap. Okay, over a closed circuit C. So t cap denotes the unit vector tangential. So if you, let's say you have taken a loop like this, you've taken a loop like this, then your dl is this element. So then this element means it will be tangential to this loop. You're getting my point? So t cap denotes a unit vector tangential to C at a point and varies from the point C. Further, you may also recall from your UG classes how about flux across a surface. What is flux across a surface? That is basically B dot ds. ତମେ ମାନେ ସବୁ cos law ପଢିଛ ସେଥିରେ ପଢିଥିଲ କଣ E dot ds ନାଇଁ E dot ds over a closed surface, isn't it? Now here it is B dot ds. B dot ds means what? Ds is a small area. So you will have to integrate over the whole surface. Okay, let me um, draw it. Just 1 second. So suppose I have the surface like this, and if magnetic field is crossing like this surface, then flux is basically how much magnetic field. So ଗୋଟେ surface ଅଛି ମାନେ surface ର କଣ ଥିବ? surface is surface area has direction, right? Surface area has direction. Co direction? Perpendicular to the plane of the surface. Perpendicular to the plane of the surface. ତେଣୁ ତାର ଯଦି surface area direction ଟା ଏପଟେ ରହିଲା, magnetic field ଟା ଏପଟେ ଯାଉଛି, ତାହେଲେ so this will be my surface rotation in cap. This will be magnetic field. So B dot n cap ds. Or this is basically equal to B dot ds. ds is a vector. Then you integrate over the whole surface. Integrate over the whole surface to get the flux. This is basically a flux. Okay, clear? So if we try to compare these two, okay, from here it is E is equal to minus d phi m by dt, and from here we get E phi m is equal to b dot ds. So if we substitute over here, it will be minus d phi by d by dt b dot n cap ds. That should be equal to E dot t dl integrated over the closed circuit. Okay. So this part we have to remember. So this is basically your Faraday's law in a mathematical form. So what is it telling? If we denote total force on unit charge to the all sources by F and the force on unit charge due to all sources other than electrostatic force is F0, then what you will write? F will be equal to F0 plus ES. F0 plus ES dr. Okay. Alright. Okay. So I suggest all of you, could you just kindly go through not example one, example one, you can check from here until here. If you have any doubt, you can ask. Otherwise, we will move over to the differential. Quickly, could you just go through this part? E dot T dl integration over closed circuit is equal to minus d by dt integration over surface b dot n cap ds. ଏଇଟା ଟିକେ ପଢିକି ଦେଖିଲ ଯଦି ବୁଝିପାରୁଛ ନ ବୁଝିପାରିଲେ କହିବି ନହେଲେ we'll move over to the next section. କିଏ ବୁଝିହଉଛି ତ ନା ବୁଝିହଉନି?
Sir, why ES.dl 0?
Yes, where?
So why integration of ES.dl 0?
Yeah, so what is yes? It's written here, right? So E is basically equal to ES plus ED. What is ES? S for static,
Yes, sir.
produced by electric charges, as in electrostatics. And ED means produced by electric field can be produced in two ways, right? Here, this part, right? If you look at my screen,
Sir,
so E is basically is the sum of ES plus ED. Electric field କେମିତି generate ହୁଏ? ଗୋଟେ ହଉଛି static charge ଦ୍ୱାରା, ଠିକ ଅଛି?
yes, sir. Yes, sir.
ଆଉ ଗୋଟେ କାହା ଦ୍ୱାରା? Change in
Dynamic.
magnetic field. Change in magnetic field, right?
Yes, yes, sir.
So E will be equal to what? ES plus ED.
Yes, sir.
Static charge ପାଇଁ. So E dot dl will be equal, ES dot dl will be equal to what? ତମେ ଯଦି work done around a closed loop କଣ ହୁଏ? ES means it's a electric field ମାନେ force per unit charge, isn't it?
Yes, sir.
ସେଇଟା ଯଦି ଗୋଟେ closed loop ରେ charge ଟା move କରିକି ଆସିବ କେତେ work done ହବ? F dot ds ନା? work done ମାନେ କେତେ? ତମେ ଯୋଉ ଆଗରୁ
W.
ପଢିଛ F dot dl, right?
Yes, sir.
over a closed loop କେତେ ହବ?
Do.
Zero, right? Coulomb's law. ବୁଝିପାରିଲ ନା ନାଇଁ?
Yes, sir.
Yes. Okay. Go through it and check if you can understand or not. Next, we will move over to the next session. 5 minutes, Oji. Then we will start. Huh? Take five
Yes,
minutes. Go through this section, and then we'll move over to differential form of Faraday's law. Okay, if everything is fine, then we move over to differential form of Faraday's law. So whatever we have discussed, Faraday's law is here, right? That's what we have coming back to here. So E dot dl over a closed circuit is equal to minus d by dt b dot n cap ds over that surface. ମାନେ ଯଦି ଏଇଟା ଗୋଟେ closed loop ହେଲା ତାହେଲେ ଏଇ ଯୋଉ surface ଟା ରହିଲା ସେଇ surface ଟା ହଉଛି S. Okay, this must be clear. Now coming back over here, ଆମେ ଏଇଟାକୁ ଆଗ ଟିକେ ବୁଝିବା. Stokes theorem mathematical physics ରେ ପଢା ହେଇଥିବ ମନେ ପଡୁଛି? Mathematical physics ରେ
ଆଜ୍ଞା
vector calculus ରେ ପଢା ହେଇଥିବ. A dot dl integration over a closed circuit or closed loop C is equal to dot del cross A dot ds over the surface S. So this if this is the loop C, then ଏଇଟା ଗୋଟେ loop C ହେଲା ତାହେଲେ ଏଇ surface ଟା ହିଁ ହଉଛି S. Okay, clear? Now if we
sir.
apply the same equation, Stokes law here, so instead of E dot dl, what exactly we write? Del cross E dot ds, right? On the left hand side, earlier कौन ଥିଲା? E dot dl integration over closed loop C. So that will converted into now del cross E dot ds from this equation, isn't it? Now that should be equal to B dot n cap ds or B dot ds. Okay. Now if we take this derivative inside the integral, so that will become del B by del T because we don't know if B has any other dependence or not, or ds this part is changing or not. So that's why we have a del over here. Okay, partial derivative with respect to time. Partial derivative with respect to time.
Sir,
Now
again,
can we no ଏଇଭଳିଆ
sir,
ଯଦି
how?
d by dt ଟା ଭିତରକୁ ଆମେ ଯେତେବେଳେ ଇଣ୍ଟିଗ୍ରେସନ କଲା ବେଳକୁ ଏଇଟା ଗୋଟେ କଣଟା b ଡଟ୍ ds ଏଇଟା କଣଟା ଫ୍ଲକ୍ସ ଟା ରାଇଟ୍
ଆଜ୍ଞା
ଏଇଟା ଗୋଟେ ଫ୍ଲକ୍ସ ଟା ବର୍ତ୍ତମାନ d by dt ଟାକୁ ଯେତେବେଳେ ମୁଁ ଭିତରକୁ ନେଇଯିବି ଇଣ୍ଟିଗ୍ରେସନ ଭିତରକୁ
ଆଜ୍ଞା
ଠିକ ଅଛି ତାହେଲେ ମତେ କଣ କରିବା ପାଇଁ ପଡିବ is my surface changing my surface is not changing right
yes, sir.
my surface is not changing what exactly changing is my magnetic field isn't it magnetic field ଟା with time change ହେଇଯାଉଛି
Yes, sir. Yes, sir.
so that's why del b by del t but magnetic field ର ତମେ plus 3 ରେ ପଢିଥିବ B ର ଯୋଉ dependence ଟା it will have some R and T ତାର କିଛି ମାନେ position dependence ଗୋଟେ particular position ରେ magnetic field will change right
Yes, sir.
ଆମେ ସାଧାରଣତଃ ଗୋଟେ ବାର ମ୍ୟାଗ୍ନେଟ ରେ ରଖିଛୁ ବାର ମ୍ୟାଗ୍ନେଟ ରେ ଏଠି ଯେତିକି magnetic field ଏଠି ତ ସେତିକି magnetic field ନୁହେଁ ଏଠି ତ ସେତିକି magnetic field ନୁହେଁ so it will depend on position but at the same time it will also depend on time okay so that's why it is a partial derivative okay
Yes, sir.
now if you compare this and this you can clearly write del cross E is equal to minus del V by del T del cross E is equal to minus del V by del T the left hand side is the interesting part is on the left hand side what is del definition টা one I cap del
Del
by
by
del
del
x
x, take
j
up del.
cap del by del y plus k cap del by del z. So del cross E means it is a with respect to space, not time. with respect to space, how exactly it is, whether there is a curl or not, right? କେତେ ମୋଡି ହେଇକି ଅଛି electric field ଟା କେତେ ବଙ୍କା ହେଇକି ଅଛି, and that is related to, on the right hand side there is no, মানে left hand side ରେ କଣ del by del x, del by del y, del by del z, ମାନେ with respect to position or space. On the right hand side it is time. So space differential is related to time differential over here. Interesting part. Okay, but this is what we have to, this is what we have to remember. This is what we have to remember, that the differential form is basically del cross E is equal to minus dV by del U. Okay, can we go through this example 1.2? Is related to this part of the Maxwell's equation. Let me tell the question, then you can try to understand the answer. Okay, कौन कहूची a rectangular wire loop, ଗୋଟେ rectangular wire loop ଅଛି, size केते L cross W, L cross length L, width W, is lying in the xy plane in the region of uniform magnetic field. Uniform magnetic field माने magnetic field टा change होउनी, ठीक আছে? Uniform magnetic field pointing in the z direction. যদি x y z ଅଛି ତାହେଲେ ଏଇ ଉପର ଡିରେକ୍ସନ ରେ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ପଡିଛି, ଆଉ ଏଇଟା ହଉଛି ଲୁପ୍ ଟା, ହେଲା? ଫିଗରରେ ସେଟା ଏକ୍ସପ୍ଲେନ କରିଛି. The magnitude of the magnetic field is increased at a constant rate from b equal to 0 at time t equal to 0 to b is equal to b naught at time t equal to t naught. ମାନେ t equal to 0 ରୁ ଯେତେବେଳେ ଟାଇମ ହେଲା କେତେ t1, ସେତେବେଳେ ଏଇଟା ଭେରି କଲା କୋଉଥିରୁ, 0 ରୁ, ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ 0 ରୁ b0. Okay, thereafter the magnetic field is held constant until time t2 and then reduced at a constant rate from b0 to b. ତା ମାନେ କଣ ହେଇଛି, ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଟା ପ୍ରଥମେ 0 ଥିଲା, କନଷ୍ଟାଣ୍ଟଲି ତାକୁ ଇନକ୍ରିଜ କରାଗଲା ଅପ ଟୁ ଟାଇମ t1, t1 ରୁ t2 ସେଟା ସେଇ କନଷ୍ଟାଣ୍ଟ ଭ୍ୟାଲ୍ୟୁ ରହିଲା. ଯଦି ମୁଁ ଟ୍ରାଏ ଟୁ ଡ୍ର କରିବି, ମାନେ 0 ଥିଲା ଏଇଭଳିଆ ବଢିଲା, ତାପରେ କନଷ୍ଟାଣ୍ଟ ରହିଲା, ତାପରେ କମିଗଲା. So this is my t1, this is my t2, this is my t3. ଏଇ ଏଇ ଆକ୍ସିସ ରେ କଣ ଅଛି, ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ, ଆଉ ଏଇ ଆକ୍ସିସ ରେ ଟାଇମ. ହେଲା, ବୁଝି ହଉଛି? So it reduced from B0, B equal to B0 to B equal to 0, time t equal to 3. Compute the magnetic flux through the rectangular loop as a function of time. First कौन करिबो, flux टाकू as a function of time compute को बाहर करिबो. Compute the induced EMF in the rectangular. Induced EMF केन बाहर करिबो, minus d5 by dt, minus d5 by dt. तो माने d5 जदि तुमे फ्लक्स टाकू with respect to time बाहर करूछ, ता डेरिवेटिव बाहर कले कोन बाहर, induced EMF टा पाइबो. And third bit कहूची what is the direction of induced current. Induced current to direction को पटे हबो, such that it will oppose the cause, जो right, जो cause पाई induced EMF हैला, से cause टाकू सी कोन करिवो, अपोज करिया पे चेष्टा करिवो. ओके, क्वेश्चन टा बुझियला. एग्जांपल 1.2 बुझियला त?
Yes, sir.
Okay, try to look at the answer if you are able to understand or not, otherwise I will explain. Again 5 minutes, go through it. ଯଦି ବୁଝିପାରୁନ, then I will explain, otherwise we will move to next section. ହେଲା, ଦେଖ ଟିକେ ଭଲ problem ଟା, ମାନେ it will make you understand what exactly this Faraday's law is all about.
Mm.
କଣ ହେଲା ବୁଝିହଉଛି ନା ବୁଝିହଉନି?
So the value of the magnetic field B0 T by T1 is not given in the question. So where it comes in the solution?
B0, no. See, it was, look at this diagram. Look at this diagram. Okay. The magnetic field is also similar. This diagram, A diagram ଟାକୁ ଦେଖ, A diagram ଟାକୁ. Magnetic field ଟା କୋଉ ଭଳିଆ change ହେଲା? ମୁଁ ଗୋଟେ draw କରିଥିଲି କୋଉଠି ଗୋଟେ।
increase କଲେ ତାପରେ constant ତାପରେ fall ହେଲା।
ହଁ, ତେଣୁ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ର ଭ୍ୟାଲୁଟା ଯଦି ଆମେ ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଭର୍ସେସ ଟାଇମ ପ୍ଲଟ କରିବା ତାହେଲେ
yes
କଣ
sir,
ହେଲା ପ୍ରଥମେ ଇନକ୍ରିଜ ହେଲା 0
yes
ରୁ
sir, T1,
B0 B0
ଆଜ୍ଞା,
B0 ରେ କନଷ୍ଟାଣ୍ଟ ରହିଲା ତାପରେ ଡିକ୍ରିଜ କଲା ଏଇ ଯୋଉ କେତେ ଯାଏ ଗଲା T1
yes sir,
ନା ନାଇଁ
yes sir,
ଏଇଟା ହଉଛି T2
yes
0
sir,
ହେଲା T3 ରେ
yes sir,
ରାଇଟ ତାହେଲେ ଏଇ ଯୋଉ ବଢିଲା ଯୋଉ the
yes sir,
magnetic field is given a bt is equal to b0 t by t1
yes
oh
sir,
okay at each point of s t ତାହେଲେ କେତେ ବଢିବ
0 to B0,
0 to b0 isn't it
yes sir,
ତାହେଲେ ଯେତେବେଳେ ଟାଇମ ଟା ସେ କହୁଛି for time t in between 0 and t1
yes sir,
ମାନେ t equal to 0 ବେଳେ କେତେ ହେଇଯିବ ତ তুমি ଯଦି ଏଇ ଯୋଉ ଏଇ ଇକ୍ୱେସନ ଟା ଯୋଉଟା ଦେଇଛି t
ହଁ,
equal to 0 ପୁଟ୍ କଲେ b is equal to 0 t
yes sir,
equal to t1 ବେଳକୁ b equal to b0 ଏବେ ଜାଣିପାରିଲ
yes sir,
ବୁଝିଗଲା ତ ଯେ bt ଟା କାହିଁକି b0 t by t1 ହବ ଏଇ ପାର୍ଟ ଟା କ୍ଲିୟର ହେଲା ନା ହେଇନି
ହେଲାନି sir, ଏଇ straight line equation ପଡିଲା କି sir?
ନାଇଁ ନାଇଁ ତମେ ଏଇ b is equal b let me write that here
Yes sir,
let's bt is equal to b0 t by t1 बाकी तो z cap टा direction that is
yes
fine
sir,
okay at t equal to 0 what is b0 b0 value କେତେ ହେବ ଏଇ ଯଦି ଫର୍ମୁଲା ଟାକୁ ୟୁଜ କରିବା ତାହେଲେ b0 value
B,
କେତେ ହେବ
0,
0 at b is equal to t1 ତାହେଲେ କେତେ ହେବ b0 t1
B0,
by t1 that will be equal to b0 ଏବେ ଜାଣିହେଲା ଆଉ ସେଟା linearly ବଢୁଛି ସେଟା ତ linearly ବଢୁଛି ନା ନାଇଁ ଏବେ ବୁଝି ହଉଛି
yes sir,
ତାହେଲେ ଦେଖ ତାପରେ ପାର୍ଟ ଗୁଡା ଜାଣିପାରୁଛ ନା ନାଇଁ ଟିକେ ଦେଖ a very nice problem actually this will explain basically how exactly Faraday's law works ହେଲା ବୁଝିହେଲା?
Yes, sir.
Are you getting it?
Yes, sir.
Good. And basically, this kind of problems are very important from exam point of view also. Eh? So first, what you have to do is basically you have to find out phi m over here, phi m over here, phi m over here. Once you get the value like this and this and this, then it's just basically taking a derivative over here. Derivative. Aku derivative nele with respect to t, so it will be b0 lw by t1. এটা constant ଅଛି ତେଣୁ 0 ଏଠି କଣ ଅଛି minus sign ଗୋଟେ ଅଛି so minus minus will become plus so that will become b0 lw by t3 minus t2. You can see in all of these lw is basically lw so ତା ମାନେ କଣ ଏଇଟା ହଉଛି l ଏଇଟା ହଉଛି w rectangular loop ର ତା ମାନେ ସେଟା ଏରିଆ ଟା ହେଲା ତାହେଲେ b0 into area by t3 minus t2 here. In the first case, it is T1 because it is basically nothing but T1 minus 0. So that is why it is T1. Okay. So here the induced EMF is negative corresponding to this part over here. Then induced EMF becomes 0. Then induced EMF becomes positive. So if this cycle continues, what will happen? It will basically oscillate between this, and then the next part it will become 0. The next part it will become negative. Then it will move positive like that only. Okay. Clear? So can we go through quickly this example? I'm not discussing the problem here. Just go through this problem. What exactly is happening? You are introducing one loop into a magnetic field region. ଏଠି କଣ ହେଲା ଫାର୍ଷ୍ଟ ପ୍ରୋବ୍ଲେମ ରେ ଅଲରେଡି ଥିଲା ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଟାକୁ ଚେଞ୍ଜ କରାଯାଉଥିଲା ଏଠି କଣ ହଉଛି ସେକେଣ୍ଡ ପ୍ରୋବ୍ଲେମ ରେ କଣ ହଉଛି ମ୍ୟାଗ୍ନେଟିକ ଫିଲ୍ଡ ଗୋଟେ ରିଜିଅନ ରେ ଅଛି ସେଠି ଗୋଟେ ଲୁପ ଟେ ଇଣ୍ଟ୍ରୋଡ୍ୟୁସ କରାଯାଉଛି ହାଉ ଏକ୍ସାକ୍ଟଲି ଆମର ମେନଲି ବୁଝିବାର ଅଛି ଯେ ଏଇଟା କେମିତି ଆସୁଛି ଏଠି କେମିତି ଆସିଲା ଆଉ ଏଇଟା ଏଠି କେମିତି ଆସୁଛି ସମସ୍ତେ ଟିକେ quickly go through that so that is the second this is the first way first example ରେ ଯୋଉଟା ଦିଆଗଲା ସେଟା ହଉଛି magnetic field change କରିକି induced EMF generate କରିହବ second ରେ କହୁଛି associated area ଟାକୁ change କରିକି magnetic field generate କରିହବ କେମିତି ହଉଛି just look at the problem and then we will move to the third part ଏତିକି ବୁଝିଲେ ଆମେ ତାପରେ magnetic କେମିତି ମାନେ wave ଟାକୁ generate କରିବା ସେଇ କଥା discuss କରିବା ହେଲା all of you kindly go through let me take some କଣ ହେଲା ବୁଝି ହଉଛି ସମସ୍ତେ ବୁଝିପାରୁଛ? Are you getting it?
Hmm.
Okay. So then with this understanding, ଆଉ ଗୋଟେ special problem ବି ତମକୁ ଏଠି ଦେଇଛି. You can try instead of uh, just one loop, you can have a solenoid. All of you know, right? What is a solenoid? Solenoid is basically you have a cylindrical support and then wire is wound over it, right? So that is basically your solenoid. ତାହେଲେ solenoid ହେଲେ କେତେ EMF induce ହବ? Induced EMF ର value କେତେ? ହେଲା? ଆଉ induced EMF ଜାଣିଲେ ତମେ basically EP ଯୋଉଟା ତାକୁ ବାହାର କରିପାରିବ. So check it. I hope you will be able to understand it. But let us try to concentrate on this page, page number 24. Page number 24, where it is kind of summarized over here. So E dot ds over the closed surface is equal to charge enclosed divided by epsilon naught. Electric flux through a closed surface is proportional to charge enclosed. Important is enclosed. Charge enclosed by that surface. And if we write Q is basically equal to what? ଏଥିରେ ତମେ ସମସ୍ତେ ଜାଣିଛ ଏଇ ଇକ୍ୱେସନ ଟା ଯୋଉ ଆସିଛି ଆମେ କଣ ଲେଖିପାରିବା? ଲେଫ୍ଟ ହ୍ୟାଣ୍ଡ ସାଇଡ କୁ କଣ ଲେଖିପାରିବା? ୟୁଜିଂ ଗସ୍ ଡାଇଭରଜେନ୍ସ ଥିୟରମ୍. ଗସ୍ ଡାଇଭରଜେନ୍ସ ଥିୟରମ୍ ୟୁଜ କଲେ del dot E dv integration over V. Right hand side will be Q is basically rho dv integration over V divided by epsilon naught. So that is from there we will get del dot E is equal to rho by epsilon naught. So this is the upper one is basically your The upper one is basically your integral form and lower one is differential form. So you must remember both integral form and differential form of Maxwell's equation because that will be the base of understanding electromagnetic waves. Second one is Gauss law for magnetic field. What is that? The total magnetic flux through a closed surface is zero. The total magnetic flux through a closed surface is equal to zero. Similarly, B dot ds over a closed surface is equal to zero. So B dot ds we can write del dot B into dV, right? This equation we can simply write del dot B dV integration over V is equal to zero. And since dV is just an arbitrary element, it will not be zero. So that means del dot B has to be equal to zero. Del dot B has to be equal to zero. So this, what does this imply? This implies so lines are always closed. There is no open lines. So therefore, there is no isolated magnetic charge. Magnetic pole ସେଥିପାଇଁ କିଛି ନାହିଁ ହେଲା ସେକେଣ୍ଡ ପାର୍ଟରେ କହୁଛି ଆକୁ ଯଦି ଆମେ ଟିକେ ଖାଲି ଏକ୍ସପ୍ଲେନ କରିବା ତମେ ତମର ମନେ ଥିବ ଯେ ଯଦି ଲେଟ୍ ମି ଡ୍ର ଇଟ୍ and explain ଯଦି ଗୋଟେ ପଜିଟିଭ ଚାର୍ଜ ଟେ ଅଛି ତାର ଇଲେକ୍ଟ୍ରିକ ଫିଲ୍ଡ କେମିତି ହୁଏ away from the charge isn't it
Yes, sir.
ଏଭଳିଆ ଯଦି ନେଗେଟିଭ ଚାର୍ଜ ଟେ ଅଛି into the charge
In
isn't it but magnetic field ରେ କଣ ହବ ଯଦି ଆମେ ଗୋଟେ let's say bar magnet ନଉଛେ north south ତାହେଲେ ସବୁବେଳେ ସେ କଣ ହେଇଥିବ ସେ ଲୁପ୍ ଫର୍ମ ରେ ଥିବ ଏମିତି ହେଇପାରିବ ଆକୁ ଯଦି ଆମେ ଭାଗ କରିଦେବା ପୁଣି କଣ ହେଇଯିବ ଏଠି ସାଉଥ ଏଠି ନର୍ଥ ଜେନେରେଟ ହେଇଯିବ ନା ନାଇଁ ସେଇ କଥା ଆମେ ସ୍କୁଲରେ ପଢିଥିଲେ ତ
yes, sir.
so it will always occur in pairs it will always occur in pairs so that there will be a closed loop ଏମିତି ଗୋଟେ ମିଳିବନି ଯୋଉଠୁ ପାଖରୁ ଆଇଦର ଫିଲ୍ଡ ଟା ବାହାରିକି ପଳଉଥିବ ବା ସେଇ ପଏଣ୍ଟ କୁ ଫିଲ୍ଡ ଟା ପଶିକି ଆସୁଥିବ ହେଲା so that is why this statement coming back del dot b equal to 0 Faraday's law electromagnetic induction that we already discussed. Now del cross E is equal to del cross E is equal to minus del V by del T. Okay. Next one is Ampere's law. Ampere's law for steady currents. So what happens? Ampere's law. Ampere's law कौन कौन It is similar to what we discussed like Gauss law. Gauss law for current जोटा हमें charge जाए बोलते ଏଠି ବି ସେଇଭଳିଆ Gauss law for current. So Ampere's law for steady currents. So B dot dl is equal to mu 0 I enclosed. ଏଠି କଣ ଥିଲା charge enclosed 1 by epsilon naught charge enclosed ଏଠି mu naught current enclosed left hand side ରେ ସେଠି ଥିଲା E dot dl ସେଠି B dot dl okay so B dot dl again if we try to apply our Stokes law so that will be del cross B del cross B will be equal to mu naught into J. Del cross B is equal to mu naught into J. J is current density or current per unit surface. Current per unit surface. এই পার্টটা জানিপারছো তো সমস্ত ମୁଁ ভাবছি এটা বুঝিପାରିବ so del dot dl this is ମୁଁ ଖାଲି ଟିକେ କରିଦିଏ so this will be equal to del cross B del cross B
Yes.
just a second somehow it is so okay. Yeah, no, yeah. So just 1 second, my pen is somewhat. So this will be del cross B ds. Okay, and this will be equal to mu 0. I enclosed is basically what? J ds, right? So if you compare these two, so then this part has to be equal to this part. So that's why del cross B is equal to mu 0 into J. Okay. ତେଣୁ ସମସ୍ତେ ଟିକେ କେୟାରଫୁଲି ଏଇ ଯୋଉ ଟେବୁଲ ଟା ଦେଇଛି ଆକୁ ପୁରା ମୁଣ୍ଡରେ ନିହାତି ରଖିବା ପାଇଁ ପଡିବ। Yes, somebody is telling something. ଏଇ ଯୋଉ ରାଇଟ ହ୍ୟାଣ୍ଡ ସାଇଡ୍ ରେ ଟିକେ ଟିକେ ମ୍ୟାଥମେଟିକ୍ସ ଦେଇଛି ସେଇଟାକୁ ବି ଟିକେ ଧ୍ୟାନ ଦଉଥିବ କାରଣ ମାନେ ଏବେ ଭେକ୍ଟର ଆଲଜେବ୍ରା ମେ ବି ଭୁଲି ଯାଇଥାଇପାର ବଟ୍ ଏଇ ଯୋଉ ଛୋଟ ଛୋଟ ଇକ୍ୱେସନ ଛୋଟ ଛୋଟ ପ୍ରୁଫ ଗୁଡା ମନେ ଥିଲେ ଇଲେକ୍ଟ୍ରୋଡାଇନାମିକ୍ସ ଟା ବୁଝିବା ଟିକେ ସହଜ ହବ ହେଲା। ନେକ୍ସଟ ଇଜ ଜେନେରାଲାଇଜ୍ ଏମ୍ପିୟର୍ସ ଲ। ଜେନେରାଲାଇଜ୍ ଏମ୍ପିୟର୍ସ ଲ କଣ? What exactly it is telling? So del ଏଠି ଗୋଟେ ତୁମକୁ ଦେଇଛି ଯେ del dot del cross is equal to 0. Del dot del cross A for any arbitrary vector A is equal to 0. eh? So you have from Maxwell's fourth law or Ampere's law, not Maxwell's fourth law, Ampere's law, what you get is del cross B is equal to mu 0 J. So if you take a dot product on the from the left side, if you del dot, ଏଇଥିରେ ତମେ କଣ କରିବ left side ରେ ବି del dot କରିବ, right side ରେ ବି del dot କରିବ, left ରୁ. So del dot del cross B is equal to mu 0 is a constant, so del dot J. Now del dot del cross B is equal to what? Del dot sorry, del dot del cross B is equal to mu 0 into del dot J. But from vector calculus, del dot del cross B, divergence of a curve is what? 0. So your left hand side will be equal to 0. So mu 0 into del dot J is equal to 0. This implies del dot J is equal to 0. Del dot J is equal to 0. However, it is inconsistent with equation of continuity. ଏଇ ଯୋଉ ଗୋଟେ ପାରାଡକ୍ସ କ୍ରିଏଟ ହେଇଗଲା ତମେ ଯଦି ଏମ୍ପିୟର୍ସ ଲ କୁ ନେଇକି ଚାଲିଲ ଆଉ ଯୋଉ ଭେକ୍ଟର ଆଲଜେବ୍ରା ଜାଣିଛ ତାକୁ ଆପ୍ଲାଏ କଲ ଦେଖିଲା ବେଳକୁ ବାହାରୁଛି କଣ ଡେଲ ଡଟ୍ ଜେ ଇଜ ଇକ୍ୱାଲ ଟୁ 0 କିନ୍ତୁ ଆମେ ଜାଣିଛୁ ଡେଲ ଡଟ୍ ଜେ ଟା କାହା ସହିତ ସମାନ ହବ ମାନେ ଚାର୍ଜ ଟା ଯଦି ଫ୍ଲୋ କରିଯାଉଛି ତାହେଲେ ଗୋଟେ ଜାଗାରେ ଚାର୍ଜ ବଢିଯିବ ଗୋଟେ ଜାଗାରେ ଚାର୍ଜ କମିଯିବ ସୋ ଦ୍ୟାଟ ସୁଡ୍ ବି ଇକ୍ୱାଲ ଟୁ ଚେଞ୍ଜ ଇନ୍ concentration of charge or rho. So del rho by del t plus del dot j equal to 0. This is basically natural equation of continuity. Alright. So what will happen? So you have to add an extra term. You have to add an extra term to make it consistent. Alright. My audio is audible, right?
Sir, equation 1.5 you ବୁଝିଲେନି
Equation 1.15.
1 again. Del dot
What
z is equal to
no, I didn't get you. Can you repeat again?
del dot j is equal to 0 ଆସିଲା again del rho by
Yes.
del t plus कहाँ से कोट ଆସିଲା
हाँ, this is normal equation of continuity. माने जदि चार्ज टा गोटे प्लेस रो आ गोटे प्लेस को फ्लो करी जाइछि ताले सेटा कोन हबो बेसिकली दैट
current
शुड बी इक्वल टू चेंज इन कंसंट्रेशन सपोज गोटे चार्ज एठी चार्ज थिला সেটা কমিকি এটি এতিকি ହେଲା এଠି ସପୋଜ ଏତିକି ଚାର୍ଜ ଥିଲା ଏଟା ବଢିକି ଏତିକି ହେଲା ତାମାନେ ଏଇ ଯୋଉ ଫ୍ଲୋ କରିଗଲା କେତେ ଫ୍ଲୋ କଲା ଡେଲ ଡଟ ଜେ ମାନେ ଚେଞ୍ଜ ଇନ ଜେ ରାଇଟ
Yes, sir.
flux del dot j is nothing but flux right ତାହେଲେ ଯେତିକି ମଧ୍ୟ change in concentration right
Yes, sir.
concentration means what charge concentration means charge per unit volume that is rho
Yes, sir.
so that is basically your equation of continuity মানে যদি আমি কইবা যে টোটাল যদি চার্জটা সেম রহিলা চার্জটা যদি ক্রিয়েট হউনি কি ডেস্ট্রয় হউনি তাহলে চার্জটা বেসিক্যালি উইল ফ্লো ফ্রম ওয়ান প্লেস টু अदर প্লেস হ্যাঁ আর সেটা কাহা দ্বারা হবে সেটা হেলা মানে যদি চার্জ ফ্লো কলা তার মানে ডেফিনেটলি এটা মানে ন্যাচুরাল কথাটা যদি তোমার চার্জটা ফ্লো କରୁଛି ଗୋଟେ ପଏଣ୍ଟରୁ ଆଉ ଗୋଟେ ପଏଣ୍ଟ ତାହେଲେ ତମର ଚାର୍ଜ କନସେନ୍ଟ୍ରେସନଟା ସେ ଦିଟା ପ୍ଲେସର ଚେଞ୍ଜ ହେଇଯିବ କାରଣ ଚାର୍ଜଟା ଫ୍ଲୋ କରି ଯାଉଛି ନା
Yes, sir.
so that is basically your equation of continuity
Yes, sir.
କାରଣ del rho by del t plus del dot j ହେଲା
Yes, sir.
କିନ୍ତୁ ଆମେ ଯୋଉ ମ୍ୟାଥମେଟିକ୍ସଟା କଲୁ ମାନେ from Ampere's law କଣ ଦେଖିଲୁ ଯେ del dot j should be equal to 0 but ଏଠି ଗୋଟେ ତ ମାନେ del 0 plus 0 is 0 but problem is it is not reproducing equation of continuity ये କହୁଛି charge flow ହଉଛି but concentration ବାବଦରେ କିଛି କହୁନାହିଁ
Yes,
so
sir.
information is ମାନେ ଟୋଟାଲ କଥାଟା ଆମକୁ ଜଣା ପଡୁନି ତେଣୁ ଆମକୁ କଣ କରିବା ପାଇଁ ପଡିବ ଏଇ ଯୋଉ ଇକ୍ୱେସନ ଆମେ ଲେଖିଲେ ଆମ୍ପିୟର୍ସ ଲ del cross b is equal to mu 0 j plus ଆଉ ଗୋଟେ ଟର୍ମ ଏଡିସନାଲ ଟର୍ମ ଆମକୁ ରଖିବା ପାଇଁ ପଡିବ ବୁଝି ହଉଛି ନା ନାଇଁ
Yes, sir.
ନା ଯଦି ମୁଁ del ଡଟ୍ ନେଇଯିବି ବର୍ତ୍ତମାନ ବୋଥ ସାଇଡ ରେ କାହାର ଇକ୍ୱେସନ 1.16 ର ବୋଥ ସାଇଡ ରେ ଯଦି ମୁଁ del ଡଟ୍ ନେଇଯିବି ତାହେଲେ କଣ ହବ ଲେଫ୍ଟ ହ୍ୟାଣ୍ଡ ସାଇଡ ଟା କଣ ହେଇଯିବ del ଡଟ୍ del cross b which is 0
Yes, sir.
right hand side will be equal to mu 0 del dot j plus del dot x equal to 0 ନା ନାଇଁ
Yes, sir.
এইଟାକୁ ଯଦି ମୁଁ କଣ କରିବି ନା ଇକ୍ୱେସନ ଅଫ କଣ୍ଟିନ୍ୟୁଟିରୁ ଏଇ ଯୋଉ ଇକ୍ୱେସନ ଅଫ କଣ୍ଟିନ୍ୟୁଟିରୁ ମୁଁ del dot j ଜାଗାରେ ଯଦି ଲେଖିଦେବି ମାଇନସ ଅଫ del rho by del t ସରି ଯଦି del dot j ଏଇଟା ତ ସବୁବେଳେ ସତ ନା ଏଇଟା ମାନେ ଅବଜର୍ଭ ଫ୍ୟାକ୍ଟ ତାକୁ ଯଦି ମୁଁ ସବଷ୍ଟିଚ୍ୟୁଟ କରିଦେବି ତାହେଲେ କଣ ପାଇବି mu 0 del rho by del t plus del dot x is equal to 0 right but what is rho
Volume density.
law this is basically from here to here ଏଇ ଯୋଉ step ଟା ଆସିଲା this is basically Gauss law del dot ଆମେ ପଢିଛେ ପରା del dot e is equal to rho by epsilon naught ପଢିଛେ ପରା
Yes, sir. Yes.
so rho is equal to what do you mean what is the value of rho is equal to epsilon naught into
Delta T.
del dot e right ସେଇ କଥା ହିଁ ସେ ଲେଖିଛି
Yes, sir.
epsilon naught into del dot e del by del t now if you have that so we find that from equation 1.19 it's satisfied if we write ମାନେ ଏଇଟା satisfy କେତେବେଳେ ହବ ଯଦି ଆମେ ଲେଖିଦବା ଠିକ ତାର ଅପୋଜିଟ ଏଇଟା ମାଇନସ ଗୋଟେ ଜିନିଷ ମନେ ରଖ टाइम ଆଉ स्पेस दे आर नॉट इंटरडिपेंडेंट माने टाइम टाको स्पेस रे एक्सप्रेस करियोबनी कि स्पेस टाको टाइम रे एक्सप्रेस करियोबनी तेणु दे आर
Yes,
म्यूचुअली एक्सक्लूसिव तेणु तमे जदि आगो डेरिवेटिव विथ रेस्पेक्ट टू स्पेस नउच तापर डेरिवेटिव विथ रेस्पेक्ट टू टाइम नउच जो रिजल्ट पाइबो तमे जदि आगो डेरिवेटिव विथ रेस्पेक्ट टू टाइम तापर डेरिवेटिव विथ रेस्पेक्ट टू स्पेस नबो तमे सेम रिजल्ट पाइबो
yes, sir.
ठीक अछि ताहले এই ইকুয়েশন 1.19 রে ইকুয়েশন 1.19 ରେ ଯୋଉ ଡେଲ ବାଇ ଡେଲ ଟି ଅଛି ଡେଲ ବାଇ ଡେଲ ଟି ସେଇଟାକୁ ମୁଁ କଣ କରିବି ଏଇ ଯୋଉ ଡେଲ ଡେଲ ଅପରେଟରଟା ଅଛି ତା ଭିତରକୁ ନେଇଯାଇପାରିବି କିଛି ଅସୁବିଧା ନାହିଁ କାହିଁକି ନା ମୁଁ ଯୋଉ କଥା କହିଲି ଡେରିଭେଟିଭ ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ ସ୍ପେସ୍ ଫାର୍ଷ୍ଟ ଦେନ୍ ଟାଇମ because time and space are not expressed by each other ବୁଝିହଉଛି
Time and space are explicit.
exclusive mutually exclusive in this treatment ଆମେ last part କୁ ଯେତେବେଳେ ଆମେ ଆସିବା relativistic ସେଠି ନୁହେଁ ସେଠି time and space are not mutually exclusive space will change with respect with time relativity ରେ ଆମେ ପଢିଛୁ ସେଟା ବୁଝିହଉଛି ନା କିନ୍ତୁ
Yes,
ଆମେ
sir.
ଏବେ ଯୋଉ ଡିସ୍କସନ କରୁଛେ ସେଥିରେ ସେଟା relativistic ନୁହେଁ ତ ସେଇ ଡିସ୍କସନ ରେ ଟାଇମ କୁ ସ୍ପେସ ଦ୍ୱାରା ଏକ୍ସପ୍ରେସ କରିହବନି କିମ୍ବା ସ୍ପେସ କୁ ଟାଇମ ଦ୍ୱାରା ଏକ୍ସପ୍ରେସ କରିହବନି ତେଣୁ ମୁଁ ଡେରିଭେଟିଭ ୱିଥ ରେସ୍ପେକ୍ଟ ଟୁ ସ୍ପେସ ଆଗ ନେଇକି ତାପରେ ଟାଇମ ଡେରିଭେଟିଭ ନବା ଯାହା ପ୍ରଥମେ ଟାଇମ ଡେରିଭେଟିଭ ନେଇକି ତାପରେ ସ୍ପେସ ଡେରିଭେଟିଭ ନବା ବି ସେ କ୍ଲିୟର
Yes, sir. Yes, sir.
ସୋ ଦ୍ୟାଟ ଇଜ ହ୍ୱାଇ mu naught epsilon naught del E by del T mu naught epsilon naught del E by del T ତେଣୁ ମ୍ୟାକ୍ସୱେଲ୍ସ ସରି ଏମ୍ପିୟର୍ସ ମଡିଫାଏଡ ଏମ୍ପିୟର୍ସ ଲ ଟା ଆମେ ଲେଖିବା କୋଉ ଭଳିଆ ଡେଲ କ୍ରସ୍ B is equal to mu 0 J plus mu naught epsilon naught del E by del T ବୁଝି ହେଲା ନା ନାଇଁ this is called generalized Ampere's law ସମସ୍ତଙ୍କୁ ମୁଁ ଟିକେ କହୁଛି ଆଉ ଥରେ ଏଇ ପାର୍ଟଟା ବେଶୀ ନୁହଁ ଏଇ ଯୋଉ ଜେନେରାଲାଇଜଡ Ampere's law ଦେଇଛି up to ଏତିକି ଯାଏ ଆଉ ଥରେ ଟିକେ ଦେଖିଦିଅ କ୍ୱିକଲି 2 minutes and then we'll move over to integral ହେଲା ଜାଣି ହଉଛି? ଅନ୍ୟମାନେ ସମସ୍ତେ ବୁଝିପାରୁଛ ତ? ଭଏସ ଟା ଅଡିବଲ ନା ନୁହେଁ? ଶୁଭୁଛି ତ?
Yes, sir. Audible.
Okay, okay. So I suggest all of you just kindly go through it. If you understand this part, then we'll move over to the. So basically, how from this treatment that is more important. So basically, we can say that del cross B is equal to mu 0 J plus mu 0 Z D, and Z D is basically epsilon naught del E by del T. This is called displacement current density, displacement current density, and similar type of questions can be asked to find out. But most importantly, what we need to understand over here, it I am ଜାଣିଛୁ already. Del dot E is equal to rho by epsilon naught. Del cross E is equal to minus del V by T. Del dot hours now. What we know is del cross B is not only equal to mu 0 J, but mu 0 epsilon naught del E by del T. Okay. I think in this part, just let me check. Yeah. I'll possibly stop it here today. Next class, I'll be talking about the unit 2. So I suggest all of you, unit 1 is again all about Maxwell's equations and finding out what is induced EMF and current density. Okay. ତେଣୁ ଗୁଡେ ସଲ୍ଭ ଏକ୍ସାମ୍ପଲ ଦେଇଛି। ଆଜି ସମସ୍ତେ ଟିକେ ଏଇ ପାର୍ଟ ଟାକୁ ଦେଖିକିରି ପଢିଦିଅ। ପଢିଦେଲା ପରେ ଯଦି କିଛି ଡାଉଟ୍ ଅଛି we will discuss tomorrow and we will move over to the next part which is basically electromagnetic energy. I could have started today, but then I expect all of you to remember all the equations which I taught today. Maxwell's equation in different form must be properly revised before going to unit 2. ଯଦି କାହାର କିଛି doubt ଅଛି, you can ask.
Sir, equation of continuity का derivation.
Come again.
No. Sir, equation of continuity का derivation है क्या?
Equation of continuity derive କରିହବ। equation of continuity को भी derive କରିହବ। କିଛି ଅସୁବିଧା ନାହିଁ। ସେଇଟା ବି ସେଇ ଗସ୍ law ରୁ ହିଁ ଆସିଛି।
ଆଜ୍ଞା sir.
ହେଲା।
ଆଜ୍ଞା।
ଟିକେ ଚିନ୍ତା କର, ଚିନ୍ତା କଲେ ହେଇଯିବ। ମାନେ ଆଇଡିଆ ଟା ହଉଛି ଯେ ଚାର୍ଜ ଯଦି ଫ୍ଲୋ କରୁଛି ଗୋଟେ ପ୍ଲେସ ରୁ ଆଉ ଗୋଟେ ପ୍ଲେସ କୁ, ହେଲା,
ଆଜ୍ଞା।
ସେଥିରୁ ତ ଚାର୍ଜ ଫ୍ଲୋ ହେଲେ ହିଁ କରେଣ୍ଟ ଆସିବ ନା, କରେଣ୍ଟ ଆସିଲେ ହିଁ କରେଣ୍ଟ ଡେନ୍ସିଟି ଆସିବ, ହେଲା।
ଆଜ୍ଞା।
ତାହେଲେ ଆମେ ଯଦି କରେଣ୍ଟ ଡେନ୍ସିଟି ନଉଛେ ଡେଲ ଡଟ୍ ଜେ ମାନେ ଜେ ରେ କଣ ଅଛି? ଜେ ଇଜ
Current
ନଥିଙ୍ଗ
density.
ବଟ୍ I by S, surface ନା ନାଇଁ ତେଣୁ ସେ
ଆଜ୍ଞା
equation of continuity we can derive from other laws but it is a very fundamental understanding ଯେମିତି ମାନେ ନ୍ୟୁଟନ୍ସ law ଭଳିଆ ହେଲା
ଆଜ୍ଞା
equation of continuity ଟା basically it should hold good other equations must satisfy equation of continuity ମାନେ କହିବା କଥା ହଉଛି ଯେ ଚାର୍ଜ ଟା ଗୋଟେ ଜାଗାରୁ ଆଉ ଗୋଟେ ଜାଗାକୁ ଫ୍ଲୋ କଲା ତାହେଲେ ଡେଫିନେଟଲି ଫ୍ଲୋ କେମିତି କଲା ମାନେ କଣ ହବ ଗୋଟେ ଜାଗାରେ ଚାର୍ଜ କମିବ ଗୋଟେ ଜାଗାରେ ଚାର୍ଜ ବଢିବ
ଆଜ୍ଞା
ତେଣୁ ଚାର୍ଜ ଯୋଉଠି କମିଲା ଆଉ ଚାର୍ଜ ଯୋଉଠି ବଢିଲା ତା ମାନେ କଣ ହେଲା ଚେଞ୍ଜ ଇନ କନସେନ୍ଟ୍ରେସନ change in
ଆଜ୍ଞା
concentration with time change in concentration with time will give rise to
del rho
this
by del
difference exactly so that change in concentration is nothing but change in density charge density
ଆଜ୍ଞା
Hala?
ଆଜ୍ଞା
Yes, any other question?
ସାର୍ ଆଜି ମୁଁ ପଢିକି କାଲି ଯାଉଥିଲି
ହଁ ମାନେ ସମସ୍ତେ ଟିକେ ୟୁନିଟ୍ 1 ଟାକୁ ପଢିବା ସହିତ ଟିକେ ମନେ ରଖିବା ପାଇଁ ପଡିବ ସୋ ଟେକ୍ ଲିଟିଲ ବିଟ୍ ଅଫ ପେନ୍ ଯେ ମାନେ ଏଇ ଯୋଉ ମ୍ୟାକ୍ସୱେଲ୍ସ ଇକ୍ୱେସନ ଇନ ଡିଫରେଣ୍ଟ ଫର୍ମସ ଅଛି ତାକୁ ଟିକେ ମନେ ରଖିବା ପାଇଁ ପଡିବ ମୋର ସଜେସନ ସମସ୍ତେ ଟିକେ ସେ ଯୋଉ ଏକ୍ସାମ୍ପଲ 7-8ଟା ଦେଇଛି ୱାର୍କଡ ଆଉଟ୍ ଏକ୍ସାମ୍ପଲ ହଁ ତାକୁ ଟିକେ ନିହାତି ଦେଖିବ କେମିତି ବାହାର କରାଯାଉଛି ସୋ ଦେନ୍ ଇଟ୍ ୱିଲ୍ ବି ଇଜିଅର ଫର ଅଣ୍ଡରଷ୍ଟାଣ୍ଡିଂ ଟୁମୋରୋ ଯେତେବେଳେ ଆମେ ଡିସ୍କସ୍ କରିବା ଯେ କଣ ଇଲେକ୍ଟ୍ରୋମାଗ୍ନେଟିକ ଏନର୍ଜି ଗୋଟେ ୱେଭ୍ସ ଆସିଲେ ତାର ଏନର୍ଜି କେମିତି ଆମେ କାଲକୁଲେଟ କରିବା ସେତେବେଳକୁ ଏଇଟା ଆମକୁ ହେଲ୍ପ କରିବ ହେଲା
ନମସ୍ତେ
ଓକେ ସୋ ଥ୍ୟାଙ୍କ ୟୁ ଫର your attention and see you